Hey guys, so we're looking at section 17.2 for today, and the title of that is Ideas That Influenced Darwin. So if you remember from the last screencast, we were watching and learning about Charles Darwin, this researcher from England who in the 1800s did a whole lot of work with developing our current understanding of natural selection and evolution. And so in 17.2, we're going to kind of add to what we had already discussed in terms of like what Darwin actually did in collecting data and observing species in their natural habitats. And here we're going to look at other types of theories and how those theories help to influence Darwin's theory, which we're going to talk about a little bit later. So how he actually developed this idea of species evolving and changing over time. All right. So the objectives that tie in here with this section here, 17.2, we're going to talk about several different other types of scientists: Hutton, Lyell, Lamarck, and Malthus. Malthus is the only one who's not a true biologist, but we'll explain exactly why he becomes important to Darwin here in just a little bit. And then we're going to talk about this other thing called artificial selection, which is something that was done by farmers living in the 1800s and even prior to that for a very, very long period of time. Okay, so we're going to start with the most ancient stuff and the oldest scientists and kind of take us way, way back and look at those that were alive in Darwin's time back in the 1800s, and in this case, even before that, in the 1700s. So remember, back in the mid 1800s, Darwin's kind of the first person to kind of take note of all these things and how their appearances seem to either vary or were similar to one another, and how that may have come from a common ancestor. But prior to Darwin's work, there were a lot of geologists and biologists alike who were struggling to understand exactly how old the Earth was. Now, we know now that the Earth is billions of years old, right? But at the time, there were a lot of people that thought that the Earth was only a few thousand years old. The first few geologists to kind of go along and say, no, that can't be true, were James Hutton and Charles Lyell in the 18th century. So again, it's the 1700s. Both Hutton and Lyell claim that the Earth must be much older than originally thought, based on landforms and based on different rock formations and all the living things that we find here and what we understand about the Earth. And that was a really important and influential thing for Charles Darwin, because it allowed him to think, okay, if species can change and adapt to their environments, well, they do have a lot more time than maybe we originally thought, right? The change from an ostrich to an emu can take a much longer period of time. And in that case, it becomes more justifiable, right? It makes more sense if the Earth now becomes billions of years old and not just thousands of years old, okay? So Hutton and Lyell both together kind of created an important hypothesis, which is that in the formation of the Earth, in the formation of all these living things that currently exist here, that there have been lots of different types of processes that have shaped the kind of geological face of the Earth, right? So have built mountains and broken down mountains and changed landforms in different ways. And that over time then, according to Darwin, would have driven this process of evolution. So their hypothesis is something called uniformitarianism, and I think I've got that here on the next slide. But the idea is that, again, if you look at the examples, these are things that you would have heard of in the past, right? Erosion, uplifting or mountain building, decay and decomposition, all of these, according to Hutton and Lyell in the 18th century, were things that have been, here and present on the Earth for millennia, not just for a few years, but these are things that have functioned to shape the Earth for a very long period of time, right? Since the Earth has really been in existence. And so again, here's that term, uniformitarianism. This is that idea that laws of nature are constant, and that it doesn't really matter how old the Earth is in this regard, right? These same laws of nature have shaped the Earth and continue to shape the Earth and the living things found on our planet. Okay, so in other words, we call it uniformitarianism, right? It's like something is uniform, it's consistent, and it's constant. Okay. All right, so another scientist that was influential in terms of Darwin's work, and this, unlike Hutton and Lyell, this guy was not so correct. It's kind of silly actually now when we talk about this to consider some of the statements that this next scientist made. So the scientist I'm referring to is Jean-Baptiste Lamarck. We often just call him Lamarck. He was a Frenchman. He was one of the first naturalists to argue that species are not fixed over time. So what that means is that species can change over time, and we know that statement alone is an accurate statement. We know that there are lots of examples and lots of evidence for this claim that species can adapt to an environment and change according to what's needed in that environment for survival. However, where Lamarck kind of got a little bit off track and a little bit inaccurate and incorrect is he took this a little bit further and he said, okay, individuals can change according to their environments based on what they use or what they don't use. So in other words, if I wanted to become a bodybuilder, right, in my lifetime, which I don't, but let's say that I wanted to become a bodybuilder and I wanted to have like just giant biceps, right? If I lifted weights and lifted weights and lifted weights and lifted weights and lifted weights, right, my arms would become super strong. The rest of my body, probably not, if my goal is to really increase my bicep size, right? But I would develop that kind of that muscle tissue, right? According to Lamarck, he would then say that I could then pass that trait down to my offspring, meaning when I had kids, they would also have giant muscles. Okay. And that seems kind of strange if we think about it that way. The another analogy that's often used when we talk about Lamarck is this one here with the giraffes. So he would have proposed that the ancestor of giraffes was similar to, a horse or a species related to a horse, and that over time, giraffes tried to reach higher and higher food, and so over time, as they stretched their necks up, right? They eventually can learn to develop that neck tissue that gives it the ability to reach up and continue eating that food. So it says right here the giraffe ancestor lengthened its neck by stretching to reach tree leaves and then passed that change down to its offspring. What's missing here is this idea that somehow through action, like stretching of the neck, through action, like lifting weights, right? We are somehow modifying our DNA because then we can pass it on. What Lamarck didn't know at this time, because there was no knowledge of this at the time, was how DNA and genes work. Okay, so when we talk about physical traits like this, like the giraffe stretching its neck, like the flamingo here not being able to use its wings and actually fly like other birds can fly, like penguins using their wings to do things like swim, which is nuts for a bird. All of those traits, he would have said, were like learned, and then over time, that learned trait somehow became incorporated into genes and DNA, and then got passed down to offspring. Okay, he called these traits acquired traits. We know now that this type of thinking is not correct, that you can't just change something on its surface, change a behavior in a way, and then pass that down to offspring. When we talk about change over time, we mean over time. Like it's not over the course of one lifetime, it's over the course of many, many generations. Okay. So the catch with his stuff is that we don't have the ability to take these learned behaviors, the stretching of a neck, right? The lack of use of wings, the development of a bicep, right? We don't have the ability to take those behaviors and traits and actually pass those down to offspring like that. Okay, so these claims are incorrect. They're not supported with any form of evolutionary evidence. So there's nothing that exists that supports his claims that these types of inheritance patterns actually happen. Okay, and so Darwin kind of learned that to be true because simultaneously to his work, there were also a couple of geneticists doing their work in the mid 1800s as well. But again, Lamarck just didn't have that knowledge because it wasn't well known in the scientific community. The next contribution to Darwin's theory was made by actually an economist, a guy by the name of Thomas Malthus, who is not a biologist. He studied populations and population growth, specifically relating to humans. And what he noticed was that if the population of humans grows significantly and grows in a manner that's unchecked, meaning it's not limited by anything, just continues to grow, then we're going to run out of resources. Okay, so in other words, there have to be some natural limits to population growth. And we talked about this back in our ecology unit, right? We talked about exponential growth, that's that kind of J-shaped curve. And then we talked about logistic growth, which is where you have a little carrying capacity and things all kind of level off at that upper carrying capacity level. That is essentially what Malthus created, was this idea of a carrying capacity. Darwin, knowing this work, said, well, there must be something similar that's going to happen in nature. There must be a natural limitation to the development of a species over time. And one of those things that he identified was that among species, we tend to have more offspring than can survive, right? And that kind of is true across the board, especially for those types of species that sit towards the bottom of a food chain, like fish and insects. Bacteria, they tend to produce lots and lots of offspring with the knowledge that most will not survive. Okay, so for those that do end up actually surviving, the chances are greater that we're kind of saving and keeping those traits that are best for survival, because those are the individuals that survive. So Darwin said that for those individuals who do survive, they must have what we call the most favorable or most beneficial traits. They have the adaptations that are going to be helpful in terms of trying to promote survival in that population. And so those are the ones that get to survive. Those are the ones that will reproduce, and those genes end up being passed down. So over the course of many, many generations, where we're consistently passing down that same trait, okay, those very similar genes, we end up with a magnificent and large change in a population, a noticeable change. All right, so over time, these beneficial traits accumulate. More and more individuals obtain them from their ancestors, and that leads to what we call evolution, or on the slide here, evolutionary change. Okay, the last little piece of evidence, the last understanding, I should say, that Darwin had in leading up to his theory of evolution is this added component of artificial selection. So artificial selection is something that's been done ever since humans entered into what we call the agricultural revolution. So ever since we began farming food. Now we have since kind of transitioned from agriculture to industry, and we create a lot of products now and food items through factory use, but we still farm. And so there are still people that use this process. Artificial selection is a pretty cool means by which humans have the ability to alter plants and animals for a specific purpose. So when we do artificial selection, we're looking at not nature choosing the traits that are most beneficial, but humans choosing traits in species for, again, a purpose. So this is like the reason why we have different types of cattle, right? We have Angus cattle and we have dairy cattle that provide milk, and they're different colors. They have different coat colors and hair, and their growth is different. We could talk about the different types of chickens, and here we have examples of pigeons. We've done this a lot. Humans have done this a lot with birds. But when we do artificial selection, a lot of times it's with a benefit for us. Okay, that's kind of the main objective. We're creating something that benefits us in some way. All of the plants that you consume, almost every single one of them, was originally created through artificial selection. Okay, there are a lot of plants that are very similar in terms of their ancestors and their lineages. They simply differ based on what we wanted them to actually produce. So Darwin, having an understanding of how artificial selection worked, because he was aware of people that did this on a regular basis, he himself bred a species of bird called carrier pigeons, which, if you've ever heard of carrier pigeons, their job was to take messages from one place to another. They've since gone extinct, but he bred them, with those behavioral traits to take things from one place to another. So he had really a direct kind of firsthand experience with artificial selection. So with this, he said, okay, well, so these traits can become more common in a population based on what humans are choosing to see and based on which pairs of parents they're breeding, right? That creates specific offspring with specific traits. When we think about natural selection, the only real difference between that and artificial selection is that in natural selection, nature is choosing the traits that are most beneficial. Artificial selection, humans do it. Natural selection, again, nature does the choosing. And it's not so much a purposeful choice as it is simply like which traits are best for survival, right? And the ones that survive are the ones that continue to carry on the population. Okay. All right. So that's all I have for section 17.2. As usual, if you have any questions, comments, concerns, don't hesitate to reach out. But otherwise, I will see you for 17.3 in just a little bit. All right, bye.